Okay, and now I'm working alright, so I can show you quickly. So first of all, to get hold of Minsky, you go to SourceForge, which is a shareware website. I'll show you that in a moment. Let's just shut that down. I go to Chrome and bring up SourceForge. And just search for SourceForge and Minsky. One word for SourceForge. So just to zoom in again. I've lost control of this mouse now too. There's SourceForge. Let's bring it up. So you can just download it. Just click on the download button after the usual accept button. Okay, and that'll give you a copy of Minsky. Just install it on your PC. When you start it looks like this. I'm trying to get my... I can move, for some reason I can move it using this, but I'm not getting the zoom I was getting a moment ago. This has crashed as well. So what you've got here is a palette where you can draw anything you like on the palette using mathematical operators. The operators are up here, and they include, just click on something like a graph and place it on the canvas, and you've got a graph inserted. There are still bugs in Minsky, but if you can see little arrows there, you can click and change the size of an arrow. That's just putting a graph on screen. Now if I want to do some, like for example, have population growth, or just say simple mathematics, I just can type the value, put the variable A on the screen, and give it a value of, say, initial value of, say, 10, and give it a maximum of 100, and a minimum of, say, 0, and a step size of 1, for example. And I can have B, just type B, press enter, give that a, say, 23, and give it a range. Doesn't matter what the range is, I was going to type numbers in there.
Why you have taken the type as why you have taken the type as float?
Huh?
You have taken the type.
Oh, there's different types of variables, parameters, flows, but I'll show you those in a moment. Now if I just type a plus key, and I'll just zoom in so you can see the whole screen, that key zooms into the whole screen. You simply drag a wire from one input to another and attach it to one of the inputs on the graph and hit the run button, and you get the value. And I then change the value of one of the variables, and I change it over time. So it simulates anything, including basic arithmetic. And what's going on there? You've got the value of A plus B. Now I haven't got an equation there, so I need to put an equation in. You notice a little blue dot that turns up on the wire? Once I'm highlighting the wire, I can just delete the wire, and I can, for example, have let's just type C, and wire the input from A to B to C, and then attach C here. And if you now look on the other screen with the equations tab, you find C equals A plus B as an equation. So it's a general purpose mathematical tool. But that's not particularly interesting. It's even more boring than a supply and demand diagram. So I'm just going to delete that lot and say simply what a model like population growth, exponential population growth. Let's say talking about fish. Well, there's a symbol up here called the integral sign. Again, I wish I could zoom in. My control cursor's gone crazy on that front. But that, if you click on that box and place it on the screen, you get integral. And it's got it's a randomly allocated name, int1 to begin with. Let's say I call that fish. And then what I want to say is this population growth of fish is some constant value, like a rate of growth of fish. So I want to make a differential equation out of that. So Minsky makes heavy use of the right-click menu. So you press the right mouse button, and you find one of the options there is copy. So I make a copy of fish, and I've got fish over here, and I've got this is the integral of fish. So I want to multiply that by a growth rate. I'm going to make a mistake here deliberately, by the way. So I've got the number of fish multiplied by something. Well, I'll call it GR, and I'm just going to use underscore F here, and Minsky interprets the underscore as a command to make it a subscript. So that's now a parameter, and let's say it's a growth rate of, say, between, say, doubling every year, which is 100%, and 0, no growth at all. Maximum of 200%, minimum of 0, and a step size of 0.01. Then I wire this up here, and I've got the growth rate of fish multiplied by how many fish there are, integrated gives you the number of fish. Okay, and I click run and nothing happens. because I haven't actually included in here an initial value. So I want to start from fish at time 0. So I type fish underscore 0, just to, again, for a bit of formatting. And let's say that that's a parameter, and say the initial number of fish is, say, 1,000 fish. And I'm not going to make any variation, I'm just going to make that fixed, so I can put, say, it's no matter what, its value is 1,000, which is what I'm doing with those parameters there. And then I wire that to the base level, and that's giving an initial condition for an integration block. Now I can then wire that up to one of the inputs on the graph here, and hit the run key, and I get exponential growth. Okay, so it's a general purpose modelling tool. That's just using it to model anything at all. I'll give you some examples of some of the systems modelling in Minsky. Who lives? Does anybody here live near Central? Close to Central. Do you hear that bell that goes off at 9 o'clock in the morning? You don't.
Not that.
You're lucky. Okay. Anybody else? Okay. If you go through Central at 5 minutes to 9, you'll find there's a bell that starts ringing at 5 minutes to 9, Monday to Friday. And initially, my girlfriend and I thought it must be like a church having funerals. But why 5 o'clock? Why 9 o'clock in the morning, and why not on Saturday on weekends? Turns out it's actually done by the old, what do you call it, bourse, the old stock exchange. It just automatically rings at 5 minutes to 9. I'm trying to find a particular model here while I'm talking, and the bloody Windows is clearly crashed. It's not just going to load this. It's called the double pendulum. Oh, here we go. Got it finally. Okay. So this is the mathematics of what's called a double pendulum model. And what that bell, it rings at 5 minutes to 9, and it's asynchronous. Like normally you hear bells ring, it's a church playing a tune. This goes dong, dong, dong. Totally crazy pattern. And I was just complaining about it to the guy who wrote Minsky, a good friend of mine, Russell Standish, who was over in Amsterdam with me last year sometime. He said, well, it's a double pendulum. And what's going on is it's got a rotor inside the bell that hits the bell. And of course, when it hits the bell moves as well. So the simplest double pendulum is a pendulum hanging off a pendulum. Like a pendulum on an arm will just do tick-tock, tick-tock, that's how we tell time. Put a second pendulum, what happens to the final point? This is the dynamics. That's an incredibly simple equation. This is the dynamics. That's why it's asynchronous. Okay? That's what's called a chaotic pattern, or a complex systems pattern. That will go on. If I left that running for a month, it would never go back to the same point. They overlap because it's three-dimensional in that sense. You're seeing that it looks like they're intersecting, but they're actually in a three-dimensional space, they're not intersecting. That'll go on indefinitely. So that's the sort of thing in the model of Minsky. And that's a very well-known nonlinear dynamic system with a very simple set of equations and incredibly complicated behaviour. If somebody showed you these equations, that's what the equations look like. That one equation there, the rate of change of omega, the angular momentum, is the negative of the sine of the angle multiplied by the negative of the angular momentum again times the cosine of t divided by t squared. Now that's it's messy, but it's a simple equation. You would never imagine it would generate a pattern like that, and that's what complex systems are about. Simple rules give you complex behaviour, and that's what Minsky is designed to uncover. It's not the only software package that does this. There's about 10 or 20. Okay? But the unique thing it has is the capacity to model the monetary system. But what you do is you type elements on a canvas, you wire them together, and you create equations. And where that equation is a differential equation, and this actually is a differential equation, you see d omega dt, because integration is a more stable process than differentiation, all the numerical techniques use differentiation rather than integration. So what you've got to do is take an equation and restate it as an integral equation, then you've got the model. So it doesn't take long. It's a slightly cumbersome step, but it's not too hard to do. So that's just a couple examples of Minsky. What I'll show you is the reason that Minsky was invented is that when you try to model financial dynamics using this flowchart analogy, you can get lost in the flowchart. Now, who's doing accounting here? They're doing it. Yeah, okay. We talked about it earlier. So like accounting teaches double entry bookkeeping, okay? Well, Minsky actually uses double entry bookkeeping to do monetary modelling. So I'll quickly show you a very simple Minsky model on that basis. So you bring down an icon we call a godly icon. You have as many as you like. They're banking views of the economy, and they use double entry bookkeeping. So I'm going to rapidly, as fast as I can, build a basic model of a banking system. So I'm going to have reserves here. I'll just go RES for reserves to save time. Call this debt. And then have over here, say, firms. I'm not going to bother about firms having bank accounts, having anything other than bank accounts, just bank account, then workers, and then the bank itself. I pressed the help key by accident. Just call it bank. Okay. And then put initial conditions in there, so like let's say 100 in reserves, 1,000 in debt, and then assets must match liabilities plus equity. So say put 800 in the firm's account, say 200 in the workers, and 100 in the bank. And once you've done that properly, Minsky gives you a 0 on that row, making sure your initial conditions are consistent, because again, when you're modelling finance, everything has to start somewhere and end up somewhere. You can't have a flow of money that goes nowhere. Okay? That's what you're showing with Minsky. So once you've done that, you've got the basic idea of initial conditions. Click on the plus key and you get a row where you can put your first operation in. So say, for example, we have lend money. This is just a label at the moment. So I'm going to put loan, or say lend, there. And just imagine the firms only lend to banks. Banks only lend to firms, pardon me. Well, once you type lend here and lend there, you've got assets rising and liabilities rising. The equation is consistent. We may be changing the way we do this in a short while to make, I'll have to type the flow name once rather than twice, but it'll be a similar operation to here. So then if you're going to repay a loan, then you take money out of the firm's account, and because you take it out, it's taken off your amount of loan as well. You notice I made a mistake of typing lowercase r there. I've got to go back and delete the lowercase and type the capital, and then and I've got a mistake, okay, because I've got minus repay here and plus there. I'm reducing liabilities and increasing assets. That's bad accounting, so I need to type a minus in front of the repay, then it's correct. Now, I suppose you're learning debits and credits, Alan. Okay, click on options, debit and credit style. Okay, so you want to check your accounting exams? Minsky can do it for you, all right? But I prefer just using plus and minus, okay? Much the same outcome. Then you pay interest. So I'm going to have money being taken out of the firm's account, and it goes to the bank's equity. And that's now accountingly correct. And then hire workers, you've got to pay them wages. So you take wages money out of that account and pay it into this account. And then you have consumption. I was going to type C just to save time over there. So it has consumption by workers, which goes, of course, they buy the outputs off the firm sector. And then consumption by bankers, same story. That's money out of their account. And that goes to the account of the firms. And what you've now designed is the simplest possible model of a monetary economy. I haven't got the physical economy in there yet, I've got to add that, but that's the basic set of equations. Having done that, notice that there's now these inflows and outflows on the godly diagram. I'll just delete this one for the meantime. So I now want to define the model. If you just check and see the equations, what you've decided is a set of consistent equations linking those accounts together. And that's the power that Minsky brings, that it makes sure your accounting is correct in modelling monetary flows. So having done that, I now need to define what each of these are. And at the moment, we're going to be improving this over time. It's pretty cumbersome right now. If I right-click, I get an option of copy the stock variables, and I get this group thing here, and then copy the flow variables, and I get this group thing over here, That's ugly as sin. We've still got to improve that. We've tried to be clever with grouping and making them transparent, but it makes it hard. Some of the commands now don't work. I want to open that group up and I can't do it. But what I can do is zoom back out until that becomes a blank box like that, and then the correct menu command comes up. This is some of the stuff we intend improving in the program over time. So I want to ungroup all those, and ungroup all those. It's a mess because the rescaling hasn't worked properly. I'll just zoom back again, back to full scale. So I drag them around, just click and drag and move them out of the way. And I won't finish, but it just will take a bit more time than necessary, but I'll show you the basics of doing it. I'll do 2 of this bits and leave you to do it yourselves as well. So I've got lending, repayment, interest, wages, consumption by workers, consumption by bankers. Defining interest is the easiest one of the lot. I'll just drag some of these out of the way just to make things less messy. But I want to define these 2. I define interest in terms of the amount of debt outstanding, because the obvious equation is the flow of interest is equal to the stock of debt multiplied by the rate of interest. Okay? So I want to bring in a rate of interest here, and I can simply type R_L for rate of interest on loans. I could have a different one for deposits. Make that a parameter, which is one of the 4 types of flows we support, 4 types of system states, and say it's a value of, say, 5%, with a maximum value of, say, 20%, and a minimum of, say, 1%, with a step size of 1%. And now if I notice it turns blue and there's only 1 dot, that's because it's a parameter. A parameter doesn't have any inputs, whereas variables, which interest is, have an input and an output. Okay? And now to say that the interest is equal to debt multiplied by the rate of interest, just type a multiply key straight onto the canvas. Minsky will just interpret the asterisk key as the multiply key, wire up those components, and I've now defined interest as a variable, as a rate of interest multiplied by a standing debt. And that's that equation is now here. And what I do for the rest of the model, let's say I want to work about what GDP is in the economy. I basically, in these simple models, argue that GDP is the turnover of money per year going through the firm sector. Okay, the firms are producing all the output. There's a certain amount of money in their accounts. It turns over a certain number of times per year. I'm just going to say it turns over, say, twice a year. And the way I do that is using an engineering concept called a time constant. If you look in Wikipedia, you'll see a definition of a time constant. And this is the sort of thing that engineers use to work out how fast you want a shock absorber in a car to compress when you hit a bump. Now, if you have no compression whatsoever, you hit that bump and your backside feels it. Okay? If you have too much damping, you hit the bump and the car keeps on doing this for the next 50 metres. So it's fine-tuning all that stuff that's a major part of engineering. So I use those as a concept in my economic modelling. And the basic idea I have here is there's a rate at which money turns over, let's say it turns over twice per year. So I want my time constant to be 2. Okay? And what I do is I divide the amount of money by the time constant, and that gives me the rate of turnover, which I call GDP. So I'm going to define \TAU, and a backslash in Minsky, when you're defining a variable, gives you Greek. So /tau means give me the Greek letter tau, which is equivalent to T. Underscore and F for firms, just as the label. And I'm going to give that a value of, say, make it a parameter. I don't have to, but I'll make it a parameter for the heck of it. Say it turns over every half a year, which is twice per year. So the turnover rate is 6 months. Okay, so 6 months the money turns over completely. Maybe maximum of 1, minimum of 0.25. This is just, you don't have to do any of this stuff. You can just use a straight number, but I'm just making it more flexible. And say a 5% variation. So if I divide the rate of turnover, the amount of, and I then divide the amount of money in the firm's account by that turnover constant, and what I'm effectively saying is that's GDP. So I'll call this GDP, and then with that just simply drag a wire from there to GDP, and that's saying the turnover of money in the firm's account per year is GDP. And then let's say that S% of that, the share of output, let's say that capitalists get 30% of that, and maybe they might get a maximum of, say, 50%, and a minimum of, say, 20%. Again, this is just a very simple model. So I then multiply GDP by S, and I get the share that goes to capitalists, which I'll call capital Pi, PI. So I'm typing \PI here. That's profits. And in this extremely simple model, actually I should put those down the bottom here, I'll just drag it around. This can make your models look rather messy after a while, but Minsky is quite flexible on that front. So GDP minus profit, I now define as wages. So let's just go back to full scale again. There's wages. Drag it over here. Wire that up. I've now got wages defined. Then I can keep on going. I can define repayment, lending. Shall I finish doing it? Just to give you a quick show of what to do, or do you want to head off? I'll keep going, okay? But that was that reaction. So I now want to define lending and repayment. I'm going to relate those to the current amount of debt that exists. So if I have lending, new loans are based on the existing level of debt. So where's debt? See, debt's up there. So take a copy of that, right-click and choose debt, and then have a rate of lending. So I'm going to make this \TAU for tau underscore L, and give that a value of, say, 7, saying that I think loans double roughly every 7 years. When there's slow lending, they'll level every 20, let's say. Fast lending every 5. Step size of 1. I should have converted it into a parameter, but I don't need to. It's just more mathematically correct to treat it as a parameter, but I can make it a variable in a more complicated model. So there's lending. And then repayment, I'll do the same sort of story. That's going to be a case of take a copy of debt, divide by tau underscore R for repayment, give that a value, say, of 9 years. So repayment halves debt every 9 years. Really slow repayment, 20 years. Really fast, say 5. Step size of 1 again. And I then divide debt by the rate of repayment, by tau as the time constant for repayment. That gives me repayment. And I want to have consumption by workers, consumption by bankers. Well, I'm going to base consumption by workers on what's in their bank account, and consumption by bankers in what's in their bank account. And a simple little observation. This is where, doing this sort of modelling, I can include class structure inside here. And how long do you reckon workers can survive without a wage? A month? 2 months? A week? Okay. I'm going to give a very small time constant for them, because they can only survive a short while without an income. So I'm going to use tau underscore W and give that a value of, say, 0.02, meaning they can only survive a week before they run out of money in their bank accounts. Now that's extreme. You might say they can survive, say, like a quarter of a year, and the minimum, say, like 5 days, 3 days. Step size of 0.01. Again, we'll make this in terms of time at some stage. So I now grab that variable alone, divide the amount of money in workers' bank accounts by tau W, wire that to CW for the rate of consumption. Same thing for bankers now, so I need tau underscore B. Now, one of the most pivotal experiences for me was when I got to the UK, was meeting a guy I knew through Twitter, whose wife I didn't know, and I asked what she do for a living. She says she's a school teacher, but he said, yeah, but she used to work in finance, and I married her because she made more money than me. And she finally explained that she went into school teaching to get away with the stress of the finance sector. Found that was a big mistake. There's much stress in banking, I think, when teaching is banking. But she said, when I got my first paycheck, not including my bonus, it was 1/30 what I got as a banker. So school teachers get about £25,000 a year. She was saying her salary was $750,000. I reckon she should survive a bit more than a year. That's why I've got a large time constant with the banking. Having put all that together, again, it's quite a mess as you see it there. I'll just save a bit of space by dragging this over here. And then let's go back to full scale, whack a graph in here. And let's graph some of the variables. So I can graph, for example, let's graph GDP. And hit the run button. I hope I don't have a mistake. And I've got a growing GDP over time. So I've got a basic monetary model of an economy. And the equations behind it have been generated by Minsky over here. Now that's an incredibly simple model. And you want to build the physical economy in there as well, and you don't do that using godly tables. So I'll show you the most sophisticated models that exist right now done in Minsky. I hope I don't get the same crash in Explorer when I try to find it. Let's see. Okay, I'll show you one of this is one by one of my students, now works with the Bank of England as their advisor on shadow banking. And this is the model of the shadow banking sector. It is incredibly complicated. Those are all the components to it, okay? He understands it, I don't, okay? And I wouldn't want to try to talk to this to a policymaker either. So a major part of what I'm doing with Minsky in the next year, with a grant I've got from a group called the Friends Provident Foundation, is we're going to drastically simplify the interface. So all the definition stuff I showed you doing over here, which took time, I hope I know that one, took time to do that. You can actually do it in an equation tab separately. Faster to type the stuff as an equation than click and drag like that. And it doesn't, the clutter there doesn't matter all that much. That's messy, but it's not hard to understand. That is impossible to understand. So we're going to work on making that better. But this actually lets you model numerous different situations for shadow banking. Is the repo rate too high? Is there too little money inside the reserve system, etc., etc.? So he built this model as his master's degree in Minsky. And the other one is also one of my ex-students, now that I'm not teaching anymore. What do we have here? So I've got, here we go, beauty, that's the one I want. This is a model of the Portuguese economy. That's looking at it full scale, and what stuns me about this guy's work is that he started doing this 4 years ago. So out of the blue, a master student in Portugal sends me a copy of his model of the Portuguese economy. And I hadn't even attempted myself to try to build a national model because I thought, Minsky's not ready for that yet. The interface is too difficult to use. And like that screen you're looking at is 4,000 by 2,000 pixels. That's a high resolution screen. Okay? That is just the tip of the iceberg of this model, which actually sits on 100,000 by 100,000 pixels. That is probably about 40,000 by 20,000 pixels, only a tiny amount of the overall design surface. But he understands that, I don't. Okay? Again, the reason being all this stuff here is just definitions. So if I zoom in there and see what's going on there, that's defining imports. So what we intend doing is, and this huge web here is necessary because the flowchart just gets bigger as you expand more and more parts of it, but it's actually a relatively simple equation with some parameter values he's worked out by statistically estimating them on the last 4 or 5 years of Portuguese data. Now, having done that, this model, done by a guy still completing his PhD, is more accurate in hitting Portugal's economy out of sample, and actually even in sample, than the DSGE models and the computable GE models that the central bank and the Treasury use. Okay? So, back to what my point of amazement was that I can barely see his model on my giant screen, and he did this on a small laptop, which is why I thought it wasn't possible. He proved me wrong. So there's an enormous amount of range in what you can do with Minsky over time. A couple of features worth knowing about. This we have grouping, but it's badly done. Grouping is one thing we need to improve before the next version. So that thing I showed you with the transparent groups over here, that's just a pain at the moment for the program. So I realised we could add bookmarks. So we use bookmarks. Let's go and look at imports. Okay? So it makes it easy to navigate that way. So bookmarks make it easier to design an overall model. But we've got about £200,000 to develop it in the next year. I've got 2 programmers working on it now. I've never had 2 programmers before. So I hope to get a fair acceleration in the user interface. It's free. I'd really appreciate if you downloaded and played with it yourself, got a bit familiar with it, tried to build some models. We're going to improve the documentation drastically in the next year. It's going to be dreadful for the next 6 months, but we're going to hire somebody for full-time documentation, writing it well at the end. So this is a framework for modelling the economy as a non-equilibrium system. There's no need for equilibrium as an abstraction anymore. What I think is a tragedy is that economists in the 19th century knew that they couldn't model the economy as a dynamic system, so they said, let's model in equilibrium and leave it to our successors to work out non-equilibrium modelling, and they fucked up. That's the only way I can describe it. They're still obsessed with equilibrium, and there's no need for it anymore. And this technology is designed to make it possible to do non-equilibrium model. I'm finishing with another amazing model. Have you heard the expression about what's called the butterfly effect? Ever heard of that? Okay, well, it's the idea that a butterfly flaps its wings in China and it causes a hurricane in Brazil. Well, that is actually the result of a mathematical model of fluid turbulence done about 50 years ago by a mathematical fluid dynamics expert called Lorenz. And his argument was simply that we know the weather's non-linear, and yet the modelling tools we're using are linear. So he took what are called the Navier-Stokes equations, which are very complicated multidimensional models of fluid turbulence, some of the most difficult equations in physics, and he simplified it down to 3 equations with three variables. So the equation behind all this, I've got 2 models inside here, not just one. All the equations are the equation for x, equation for y, and equation for z. So there's x, y, and z are your variables, a, b, and c are your parameters. Incredibly simple model. You'd never imagine anything like that would give you complicated behaviour, and this is what you get when you run the model. And I've got 2 simulations going on at once there. So after about 12 seconds, which is the effective time here, they'll start to diverge. And after a while, there's absolutely no way that one tells you where the other one's going to be. And that's why we get the idea of the butterfly effect. That looks like a butterfly's wings. And sensitive dependence to initial conditions, because your 2 models differ by 0.0001 in the starting system. And after 12 seconds, that's been exponentially amplified to an error level so great they're 2 totally different simulations. And that's the idea of you can only predict the weather for a short time ahead, but you have to understand the structure of the weather to be able to model it properly. Now, what are economists doing? Making up a mythical world with rational bloody agents, so-called, not understanding the structure of the economy. So I want to show you one last model before we call it a night, and that is a model that I've done of Minsky's financial instability hypothesis. But the way that I built it was simply from definitions. So just like I showed you with that with the Cobb-Douglas thing beforehand, I took the definition for wages share of GDP, which is wages divided by GDP, differentiate it with respect to time, and then include the simplest possible relationship between that and employment, which is a linear Phillips curve. Same thing for profit and investment, a linear investment function. And I included firms borrowing money to finance investment. And when I simulate this model, I'll just set it up so it'll give me my stable outcome. So this is the model that I did back in 1992, published in 1995, of Minsky's financial instability hypothesis. But I now realise, rather than being a complicated thing to derive from a causal chain of logic, I can just do it from straight definitions. So the model has 3 variables and about 8 parameters. With a low level of desire of capitalists to invest, you get a system that converges to equilibrium. Well, that's a system with prices as well, so it's slightly complicated. But that's obviously a system that's converged to equilibrium. With a high level of desire to invest, it appears to converge to equilibrium. And then it collapses into debt deflation. Now, a model with that much dynamics would take weeks to months for somebody to build using dynamic stochastic general equilibrium techniques, because they've got to really complicated work. What's the utility function? What are they maximising over, what time horizon? What's the pricing system, etc., etc., etc. That took about a day to do that. So they're working really hard, and it's the same sort of story as Ptolemaic astronomers had to work really hard to make a model that roughly fitted what the planets were doing in the sky. Because they had to have circles on circles on circles and points of deviation of the centre of the universe from where the Earth was, and incredibly complicated work. Along comes Copernicus and said he said originally it was the sun's at the centre and we're on circles around it. And then we get Kepler coming in and saying, well, it's actually ellipses. And then you get Newton's equation, and bang, we've got gravitation and simple models. You've got to change your paradigm. What neoclassicals are doing is sticking with the old bloody paradigm and not willing to change. To throw them out, start all over again. And Minsky is part of a tool of how to do that. Okay.